Hello everyone, July the 8th. Alright, let's do this. Reschedule meetings from maximum free time. Integer event time, denoting the duration of an event, where the event occurs from time t equal to 0 to time t equals event time. You're also given two integer arrays, start time and end time, each of length n. These represent the start and end time of n non-overlapping meetings, where the ith meeting occurs during the time start time I and end time I. You can reschedule at most k meetings by moving their start time while maintaining the same duration. Wait, what's event time? The duration of an event. Oh, this is the duration of an event. And you can reschedule most k meetings by moving their start time while maintaining the same duration. So the end time has to move as well to maximize the longest continuous period of free time during the event. The relative order of all the meetings should stay the same, and they should remain non-overlapping. Return the maximum amount of free time possible after rearranging the meetings. Note that the meetings cannot be rescheduled to a time outside the event. So the event time determines the range, the total range, right? So you can reschedule the meetings by moving their start time while maintaining the same duration, the meeting duration. And we want to maximize the longest continuous period of free time during the event. So in this case, we start with 1 to 2, 3 to 5, and we have 1, 2, 3, 4. Oh, we actually have 4, right? So we can move this one. We reschedule at, so 1, 2 to 2, 3. So we have 0 to 2, we have 2. Or we can move this here, and then we have an event in the middle. So here we have already set up the whole thing. And then we move them around. So we have the thing in the middle, which is 6. Because we have 1, 2, 3, 4, 5, 6. Okay, so what I think this problem is, okay, I'm not sure if start time and end time are sorted, but that probably doesn't really matter, right? That probably doesn't really matter. What we want to know is, yeah. So we just find all the gaps, just adding all the gaps together, and that should be the answer, right? We just need to add all the gaps. So what we want to do is, well, sort. There's no saying that it's sorted, which means, hold on, let me just try it. They didn't say that it's sorted, so ooh, where did they say it's sorted? They didn't say it's sorted, but it's fine. Hold on, where did it say it's sorted? Oh, well, I mean, it's sorted, so I don't even have to sort. So this actually make it even simpler. All right, so we have the smallest, right? Then we know what's the largest is gonna be. And then we just go one by one, we find the gap. Like here, we start with 1, and if we plus 5, so we should end at 6, right? We should end at 6. So what we do is we find a difference. 3 and 2, that's difference 1. And 6 and 5, difference is 1. So the answer is 2. I got a bit nervous initially because a range is, depending on what type of question it is, range can be difficult. All right, but this one is pretty simple. It's 3, 4, 3, 9. Just find the sum of all the gaps among the meetings. Okie dokie. What we're gonna do is int res equal to 0 for int I equal to, oh, we can't because we have this k. Oh, okay. So we can only move most k meetings. So a little bit complicated. K meetings. Okay. So what type of gap do you think we should make? Like if I have another one here, right? If I have another one here, and we can only move one of them. So basically we have gaps. Okay, so it's a slightly more complicated. So we have, event, meetings, okay, meetings. And then this is the start, and this is the end. This is the total range, okay? So we have, gap, another gap, another gap, and another gap. So we have 4 gaps. And each time, if you move one of them, you're able to merge 2 gaps. So what we need to do is get all the gaps out. So gap 1, gap 2, gap 3, gap 4, right? We get all the gap out. We will sort this thing, right? Because every time you move one, you're merging 2 gaps. You move another one, you're merging 2 gaps. So if I can move 1, then you're merging 2 gaps. If k equal to 1, then we are merging 2 gaps, right? If k equal to 2, right? If k equal to 2, so move 1 will merge 2 gaps, and move this will also merge 2 gaps. So we can choose, but those are separate 2 gaps, right? So separate 2 gaps, I think it's always going to be, we're going to merge 3 gaps because those 3 gaps are continuous, right? If you do separate, then they are not continuous, and we'll always take the largest gaps. So we sort this, and and then we can move, like in this case, if we can move 3, right, and move all of them, 1, 2, 3, then we're merging 1, we're merging 3, we're merging 4 gaps, right? So this one is merging 4 gaps. So we are slightly more complicated, okay? Find, it's not a sum, find all the naturally occurring gaps in the current coming teeth. I will bring your teeth. continue the journey. So find all the natural gaps in the current meetings. Save them in array, sort it, and sum the k-1 largest. We can do this because each move can merge one, can merge two, right? Can merge two gaps. And it is better to always merge the largest gaps available. So that changed, right? So now we need gaps. Okay. So if end time I is minus, okay, G is end time I minus start, no, start time I minus end time I minus 1. If G is larger than 1, because if G is equal to 1, the gap, there's no gap, right? Hold a second. No gaps if they are the same. So it's larger than 0. Let me say gaps dot push back G. Okay, so we got that. Oh, we have one more. Gaps dot. You know what? Push back. Event, no, start times 0 plus k, no, event time minus end time dot size minus 1. This is the last one. So if you're not going to check, I think this will suffice. Sort gaps start begin gaps and then for int I equal to gaps dot size minus 1, I large equal to 0, I minus minus, wee, I minus equal to and k is larger than 0. That makes it much simpler, right? Plus equal to gaps I k minus minus. Now we return res. All right, let's take a look. start time I minus end time, so that's a 1. Yeah. And then we'll add another one to start time this. That'll be 6 event time minus end time 5. So we have 1, 1. Okay. Then gap size, so I equal to 1, not larger equal to 0, and k larger than 0. So rest plus equal to gaps I. That's good. K equal to 1, and I equal to 0. So add another one. I don't understand. I don't understand. It looks perfectly fine to me. That should be a simple. I see. Large equal to 0. Oh, I see. No. K is larger than 1. So we have to merge 2 first. Okay, we have to merge 2 first. So yeah, I know why. This is a little bit oversight. It's fine. So what we're gonna do is gaps dot size plus. Oh, what if it was only 1? Interesting. How can I do this? Gaps dot size minus 1. Okay, and then we say from here. There we go. This one shall do. Just a little trick. Will make it work. Just a little trick. There we go. All right. And it does not work. What the hell? What in the world? Okay, I have 7, 7, 10, 10, 14, 16, 18. So start with 7. So the end should be 8, 28. Okay. So 7 to 28. And we can move 1. So the gap is, this is a 0. This gap is 2, and this gap is 10. I don't understand. 7. How do you figure? 7. I mean, I can move this to here, so like plus 10, so it'll be 26 and 28, right? Did I understand the problem wrong? Yes. Okay. All right. It has to be event time. Hey, I did not know. I didn't read the question carefully. That is actually not right, because it is possible that it's going to get you a negative value. Well, I don't think it's going to give you a negative value. It's just... But the question remains, why is this one wrong again? Well, I mean, the end time will be smaller than the event times, right? So the event time minus the end time shall give you the gap. Oh, the gap at the front. I see, I see, I see, I see. I see. So we need to do this as well. This will be start time 0 minus 0, which is just start time. That should be right. Okay. Still not right. All the natural occurring. So this one 10. But anyway, so we are at 28. No, we're not at 28. We are at 21. Okay, so this is 21. Let me redo this. So we are at 21. So the gap, this gap is 7. And this gap is 3. Right, so if we sort them, will be 0, 2, 3, 7. And k is, because I took this, k need to minus and minus as well. So this is a first merge. Wait, hold a second. Then we do another one. Now you only have one. Oh, you are not able to get these two. Oh, wow. I was very wrong. Oh, okay, okay, okay. That's actually... Alright, so 7, 0, 2, 3. Now we're gonna merge. Merge once. Holy crap. Holy crap. Oh, that's actually harder than I had expected. The original one doesn't work. I can't sort them because 7, this and this, they don't merge. So if I merge once, merge twice, merge 3 times. So we have these, right? And then you're saying we should always find the largest to do the merge. It's a bit greedy here, right? We find the largest. Not really, not largest. So we find the pair whose sum is going to be largest. So in this case, it's going to be 7, 0. So it becomes 7, 2, 3. Right? And then we can find the next biggest. So either do this or do this. So the next biggest will be 9, 3. The next will be 12. So it'll be 7, 9, 12. But would it be possible that it actually will be possible? Like if I have a big value, some think 0 can be ignored. Right, 0 can be ignored. So we don't need to worry about 0. But yeah, so like set 0 like this. And then we have like 3, 3, 3, 3 like this. Okay, so we say maybe 5, 5, 5. Okay, maybe 5, 5, 5. So we say pick 2. Right, then would be 11. Then 1, 1, 1, 1, 5, 5, 5, 5. And so now it becomes 12. Right? And then it will become 13. And then it will become 14. So we take 1, 2, 3, 4, 4 steps, and then we only get to 14. But if I take 4 steps, that'll be 1. I actually do take 3 steps, right? 1, 2, 3. Yeah. So, holy crap. It's actually not that simple. Because the limited number of steps you can do, that makes it more difficult. And so you have a bunch of gaps. And you cannot just say, I will use the largest, because that might not work to your advantage. But it is to realize that if you want to merge, you always, so once you start merging, right, it's always better to keep merging. Does that make sense? So you don't like merge on one side and then merge on the other side, right? If you merge on one side, then you merge on the other side, then one side on the other side, it doesn't really help unless eventually they can connect, right? If they don't connect, then you just have two regions. Like, why do you have two regions? You may as well merge them together, right? So you're always starting from one point, right? You're always starting from one point and then you just go out. So that, I think, is correct. So again, you get the gap, right? You get the gap. Ignore the zeros, okay? So yeah, we have, so essentially, let me redo this. So essentially we have some numbers, G0, G1, G2, all the way to Gm, all right? And then Gi is not equal to 0. So we have that. Now the question is, I want to find basically a stretch of number, sum, right, of k minus 1. Actually, no, I think it's k, of k numbers, right? A stretch of k numbers that their sum is the largest. Let me think again. Well, I think k equal to 1. K equal to 1 is I would like to say a special case. Hold on, let me think about this one more time. We have 7, 2, 3, right? And we can move one of the events. Oh, we do need the zeros because you cannot move the whole thing, right? You cannot move the whole thing. So we have to have the zeros. We have to have the zeros. So in that case, when you say k equal to 1, so it's just every single one, right? We can move one of them, right? You can move one of them. K equal to 1. K equal to 1 means you have a window size of 2. So you add these together, that's k equal to 1. So k equal to 1 will give you like 7, 2, and 5. That's k equal to 1. And k equal to 2, the window size is actually 3. Right? K equal to 2 is 3 because now you can move to merge the 2, and you can move again to merge the 2. So k equal to 2, the window size is 3. Okay. So, wow, this is very wrong. Find all the naturally occurring in the meetings. Save them in the array. Now, we cannot sort them. Then use sliding window of size k plus 1, right? Of size k plus 1, and find the largest subarray sum of size k plus 1. So there's no sorting. We do need the gaps, but gaps.pushback start time 0. This is necessary. That's the first, and then we do everybody else. Then we do the last. This is not right. Last is just event time minus this. Don't sort. Results will equal to 0. Okay, and for we're gonna do sliding window, right, of size k plus 1. So we'll say k plus 1 window size is k plus 1. Yeah. So we'll say for I equal to 1, 0 I smaller than gaps dot size I plus plus. Okay. Now we shall say we have a res and we have current. Right. We say current plus equal to gaps I. Okay. So we always add it, and then we say if I minus 0 plus 1 is larger than k plus 1, right? So if it's too big, so I plus 1 is the total number so far, and k plus 1 is the number we can have. So we can just say if I is larger than k, right? If I is larger than k, that's a signal that current is a minus equal to gaps I minus, I would say, k, right? Hold on. So if k is equal to 1, right? K is equal to 1, then we have 2, so 0, 1. So I equal to 2, then we need to minus k minus 1. And it will be max of res and current. And then, okay, let's try this one. All right, this one looks good. So far, so good. We'll see. Yep, that's the one. that is the one. And what we realized is we don't need to, yeah, like if we want to improve the performance, we don't have to put everybody into the gap. We can just build a gap along the way. You want to do that? Well, I mean, it doesn't hurt. I mean, let me think. Okay, let me think. Now I'm too lazy. This is good enough for me. Well, we know the strategy, but just, I don't want to do it. I absolutely have no gana to do it. Alright, so this is good. Let's see, editorial. Greedy prefix sum. Is this the prefix sum? Yes. Prefix sum. Yes. You can use prefix sum as well. That is true. You find a gap and then you do the prefix sum. Yeah, it's the same, right? It's the same. We use sliding window. They use prefix sum. That's the same thing. I was going to say that's the same thing. A sliding window. Yes. You don't have to create the array. You can just, I just, I don't want to do this part, right? But it's all right. It's all right. Oof. All right, that will be it. Good. We stumble upon some wrong answer initially. I definitely didn't think it through initially. So I think like the problem, the more I think about it, the harder it becomes. But luckily, eventually we got the right